Okay, don't be too excited. So imagine we're inside a police station. I know it doesn't look like one, but try to keep that in mind. So welcome everyone to this police briefing. I've gathered here you all today to crack a serious case. This is what we know. At exactly 7:12 yesterday, RCI reported major slowdowns across all front end. Dashboard showed load times increasing to the tens of seconds. Tens of seconds means enough time to go to Twitter, check Twitter, go to Instagram, check Instagram, then go to Twitter, back again. Not only that, Sentry started lighting up like a Christmas tree. And even worse, users started contacting support. And you know it's bad when users start contacting support to tell them that the interface is slow. One thing we know for certain, our app's performance is dead. We sent 2 junior front-end engineers to investigate, and we haven't heard from them since. As of now, we have no leads, no suspect, and absolutely no patience at all. So we are here to solve this crime together. And before we do that, let me introduce myself. My name is Opher. I'm a developer, a designer, a musician, and sometimes, like in this case, I'm a fake police commissioner. And in my day-to-day, I'm a principal engineer at a company called HUD, where we have a cool platform that helps you solve production issues. Production issues are tricky and kind of hard to solve. Today you have like LLMs and code agents, but they only know the code. They don't know what's actually going out there in your servers. So what we do is we capture live service and endpoint function level data from production, and then provide that context to your AI agents so they can actually figure out what's going on and fix the problem without you having to sift through logs and all that sort of stuff. So, speaking of solving things, what does React try to solve? And the way I look at it is there's like 3 main pillars, and let's go back to front. First pillar is reusability, which means, like in the React world, components, that is encapsulated pieces of code that contain both the UI and the business logic, and let you share that across different sections of your applications. Then you have UI state management, which means like there's data coming from a lot of different places, there's input, there's stuff coming from your APIs, and then somehow you have to wrangle it all together in a way that makes sense so that when things affect each other, it doesn't turn into this huge mess. And lastly, there's efficient DOM management. Now, what do I mean by that? Basically, DOM, the document object model, is the data structure which your browser uses to figure out how your page looks and how to control interactivity, how to control the data, how to control the rendering. And every change to the page and to the data is essentially a change in the DOM. Now, a change in the DOM is actually, you have the DOM tree, and then you add stuff to it, you remove stuff to it, you change stuff in it. And if this is done inefficiently, so too many changes in too little time, the browser can struggle with it because it comes with a lot of overhead if there's interactivity involved. React solved this, or attempts to solve this, by introducing something called the virtual DOM, which is essentially the in-memory version of this DOM tree. And then changes are made to the virtual DOM in memory instead of in the presented browser instead. And the premise is that it knows how to do this intelligently by like batching changes and like delaying changes and that sort of thing. But we need to ask ourselves, like, this is all good in theory, but in practice, what does that mean? So you need to follow a certain React methodology in order to let it do its optimizations. And I said like rendering a lot of times, and we need to also ask ourselves, when does stuff get re-rendered, which is kind of like the core thing here. That's what we're trying to optimize. And let me be specific. What do I mean by rendered? So rendered could mean a lot of things. It could mean actually drawing pixels to the screen. It could mean pushing textures to the GPU. But in the context of this talk specifically, I mean calling the functional part of the functional component. So this is a React component. And when I say rendering, I mean like actually when React calls this function. So not the actual drawing to screen part. And that's a huge part of the actual part of delivering the change to your users. So what causes a React component to re-render? Few things. First, if the parent of the component re-renders, and there's an asterisk there, which we'll talk about soon. When its props change, when its state changes, or when its context changes. And this is not an exhaustive list by any means, but things aren't so simple in the real world. To help with this investigation, I've called for external assistance to figure out why our app's performance is dead. We have several detectives joining us today, and they're all going to help us discover why our app failed, common performance pitfalls, and tools to mitigate and to detect and debug these performance issues. And let me tell you, this is quite the lineup. Each detective with their own unique methods and means to discover. And our first detective is, let me check, Batman? I know, it's kind of hard to miss with the pointy ears. I didn't think we need Batman to solve performance issues, but I guess here you are. Okay, yeah, we figured that out. So what did you find?
Two problems. First, the app had use context, which kept updating all over the place. The more it changed, the more chaos it created.
Interesting. What else?
Second, it was creating new objects, arrays, functions, improps on every render. That constant churn adds up, Commissioner. It's unnecessary work. And in a case like this, unnecessary means slow.
All right, those are solid leads. Let's break that down. So Batman told us about use context. And let's do a quick recap into what use context actually means. So let's say you have a React app, and a common pattern in React that we sometimes encounter is called prop drilling. And what that means is, let's say you have a parent component that you want to pass information from that parent component down the tree into like a grandchild component. So you pass the message to the parent component, which receives it through its props. It passes that to a child component. That child passes again to a grandchild component, and only then do you use that information. You might have encountered this before. If the tree is really, really a lot of levels deep, then it gets really cumbersome to try to manage that. And to solve that, we have something called a context, which is React context, which works kind of like this. You have the create context, which is something that is like external to all of these components. In this case, we're creating this message provider, and then you see that you wrap the message provider around the parent. That is where the value comes from. And then the parent and the child don't need that at all, because they don't care about that. And then eventually, you have the grandchild, which uses the use context hook to use the message, to get the data that we wanted all along. Which is all great, but use context is actually a hidden foot gun. Have you ever heard the term foot gun? It means something that makes it really easy to shoot yourself in the foot with. React has a lot of those. And let me show you what I mean by that. So let's take a look at this like pseudo real-world example. Use this authorization provider context. So sometimes in your app you have like your users log in or whatever. You need to provide the information of like the email or username, whatever, to multiple components. So a context might be a way to easily do that instead of prop drilling. So the thing here is that assume that the payload comes from somewhere, from the API, from the actual authorization, whatever. That doesn't matter. But in the end, you provide a value. And in this case, the value is a new object that is being created. You see its value, and then there's a double parentheses and the double curly brackets. The inner curly bracket is the JavaScript way of creating a new object. And when a new object is created, there's a reference to a new object. And that means that every time the authorization provider is invoked again, you have a new reference to an object. And that means every time someone consumes this context, the components get re-rendered, which sucks because like nobody intended that to happen, but that's the end result. Here's another really similar example. Let's say that your authorization provider provides a function called authorize. And this is kind of like the exact same thing, right? The function is defined here. So every time the context is invoked, you have a new reference to the authorize function. And then you pass specifically that function to the value. And again, every component that uses this context will get re-rendered. Even if there's no actual reason for it to re-render because the function does the exact same thing. So how would you solve for this? You memoize the value. What does memoize mean? Memoization in React means a way to retain information, a way to retain value across re-renders. And how would that look? So in the case of the authorization provider, you can see that the context value uses the use memo hook, which changes only when the payload changes, and that is the value we pass on to the provider. When we talk about functions, in order to preserve the reference to the function itself, you have a different hook called use callback, which does essentially the same thing, but for functions. And then you pass along the value that the reference that comes from use callback, and you pass that along to the authorization provider. Cool. Anything else, Batman?
Optimize your renders, Commissioner. Gotham may be a mess, but your component tree doesn't have to be.
Aren't you more about like fighting crime than solving JavaScript issues?
Crime takes many forms. In JavaScript, that's the worst kind of crime.
You're not really a detective, are you? You're more about like beating people up, dressing up as a bat?
You're not really a police commissioner either, are you? You're just a nerd, standing in a room full of other nerds.
Fair enough. Thanks, Batman. Okay, so our next detective, let's see. Oh no.
Go, go, gadget, dashboard cam. Hang on. Let me just. Go, go, gadget, Bluetooth headset.
Bluetooth device is connected successfully.
Gadget, are you driving on this call?
Of course, Commissioner. Multitasking is the future of crime solving. Besides, Penny upgraded the gadget mobile. Fully autonomous. Completely safe. Anyhow, go, go, gadget performance insights.
Okay, Gadget. What do you have for us?
Do you know what happens when you pile too many use effects on top of each other, Commissioner? You get a mess. A big, tangled, buggy mess. I tried to debug it myself, but even my Go-Go Gadget debugger crashed halfway through.
That does sound inefficient.
Inefficient? Commissioner, it's a disaster.
Okay, I see the problem. What else do you have for us?
Oh, yes. Use memo and use callback. These are precision instruments. They're being used everywhere. It's like the developer thought, why not memorize everything? So now, the app is spending more time memoizing than actually doing anything. It's ridiculous.
Wait. So you're saying they turned these hooks into liabilities instead of using them as tools?
Exactly. Too much of a good thing, Commissioner. If they just stopped to think before deploying every hook they could grab, we wouldn't even be having this conversation.
Okay, thank you, Gadget.
All right, Commissioner. That's all the intel I've got. Time to head to my next mission. Someone reported a toaster that is throwing errors in production. Go, gadget. Seatbelt.
Okay, so use effect. Let's recap on what that exactly does. I'm not going to go through all the use cases of use effect because that's going to take a few hours. But let's do that, run through that really quickly. Use effect. What is that used for? Anyone? What? Some change. Okay, use effect is used for data synchronization. And you might assume from the name that use effect should be used for effects, but only as a last resort. And if you don't trust me, just trust the React documentation, which says if you exhausted all options and only as a last result, you can also handle side effects using use effect, which is just, naming things is hard. And if you want to know more about this, there's an amazing talk. Watch an amazing talk called "Goodbye Use Effect" by David Khorshid. Highly recommend using it, watching it. Sorry. So, okay. First foot gun of use effect is derived values, and what do I mean by that? Let's take a look at this example. You have a name component which receives a first name and a last name, and then it outputs the full name using use effect. So every time first name or last name changes, it sets the state for full name. But you don't really need to do that because you already have all the information to compile a full name from the first name and the last name. So you might as well just have done this. There was no need for using a set effect because that is a derived value. What it would do, it would introduce another extra render that you don't really need for the component. And this stacks up when you have multiple use effects. So you have a use effect that changes something, and that's called another use effect, and that compounds and just creates this whole huge mess. Avoid that. The other foot gun that I come across is missing cleanup for use effects. So take a look at this example. Let's say you have a hook that uses the native event listeners of the browsers to figure out what the window size is. So when the component loads, that's what happens. Like at the end, there's like an empty dependency array here, which tells the use effect load this once when the component mounts. It registers to the window resize event, and then when that happens, it changes the state to the window size. The thing is, this happens every time the component mounts. So what you end up is with a memory leak, because every time this component loads up, it does another event listener and another event listener and another event listener, and you end up with a memory leak. So what people often forget is that you actually need to clean up after every use effect. And that's why use effect is often considered to be a data synchronization tool, because usually when a component that requires to be synchronized with some external API or something like that loads, you want it to say, okay, the component just mounted. Now I'm synchronizing it to the external data source, and when the component unmounts, I'm like removing all the listeners, I'm unsynchronizing, whatever. So in this case, the use effect API is created so you return a function, and that function gets called when the component unmounts. So let's continue with our investigation. Let's see what else we have. Finally, an actual detective. Next up is Benoit Blanc. Detective, what do you have for us?
Commissioner, a most fascinating case you've presented here. A tangled web of decisions, if you will. Now, I've spent some time unraveling this mess and have come to an intriguing conclusion.
Okay, Blanc, let's hear it.
The app is guilty of two opposing sins. On one hand, it is downright negligent in its use of memoization, failing to use memo and use callback where they would have clearly reduced unnecessary renders. But on the other hand, where memoization is used, it's done so excessively and previously. Overuse or react memo on components that barely change.
Wait. So you're saying they're both overusing and underusing memoization?
Exactly. It's as if the developer couldn't decide whether to trust memoization or fear it. Instead, they've employed it haphazardly, sometimes ignoring it altogether, other times slathering it over like butter on a biscuit.
So what's the impact of this?
Chaos, Commissioner. Sheer chaos. Performance suffers where memoization was neglected, and the upwaste cycles where it's been overapplied. It's a textbook case of too much and too little, all at once.
Okay, thank you. Let's break this down. Let's talk about memoization. So, if you recall, a component can re-render if one of its parents re-render, or when one of its props change. But here's the asterisks that I mentioned before. Sometimes you don't want the component to re-render if one of the parents changed. Sometimes you want it to just stay the same if none of the props changed, which is kind of funny because that's kind of most of the time you don't want stuff to change if nothing changed. Let's take a look at the example. Let's say you have my component, that is the parent, and that component has an expensive component. And by expensive, I don't mean a component that costs a lot. I mean a component that might use more resources, like, I don't know, the CPU or memory or something like that. And for that, we have a tool called useMemo, which does memoization at the component level. So you can use react.memo to create a new higher order component called, in this case, a memoized component. And when you put that component in your component tree, it will not re-render if it's one of its parents re-renders. That is called a pure component in the React lingo. Here's the thing, though. Memoization is fragile. And by fragile, I mean it's really easy to break memoization without actually knowing that you've broken it. So you get all the downsides of using memoization. So it's like extra calls and extra memory of making React do extra things. But if you've broken the memoization mechanism itself, you get none of the benefit of all that extra work. So let's look at this example. In this case, the memoized expensive component receives children as part of its input. You see, there's the new P hello world thing. Here's the thing. Every time you put in new components like this as part of the children, they again create new references to the new instances of the functional components. In this case, the P. So while memoized expensive component is memoized, the children prop, which is it is a prop, it's just not in the props area, has a newer reference, and the component will re-render, even though you didn't want that at all. So one way to solve this is actually to memoize the children themselves. So see now the children, the P is up on top, and you have a memoized children, which I know it looks a little excessive, but that's one way to go about this. Another thing that I see a lot is that, let's say you've memoized your component and everything works perfectly, and then like further down the line, maybe another front-end engineer comes and adds styles or like new CSS or something to the component that you've previously created. Now, your component probably isn't called memoized component. It's called, I don't know, table wrapper something something. So they don't know the component it's memoized. And when they eventually add a style or whatever, again, they create this, reference to a new object, and then they break memoization again. So that's why it's tricky. It's hard to maintain that memoization across the code base history all the time. So you need to be mindful of that. Next up, we have, let's see, a professional from the FBI. What do you think about this case?
Something doesn't add up here. These aren't normal performance issues.
Okay, what do you think is causing them?
Have you considered external interference? Forces beyond our understanding?
You mean like what?
There are beings who have been known to interfere with JavaScript runtime environments. They're trying to disrupt humanity's progress in web development to keep us from advancing too quickly.
Right, and these beings, how are they messing with React exactly?
They're introducing unnecessary re-render through an advanced psychic feedback loop. Think about it. Have you ever actually seen a virtual DOM? Or are we just taking React's word for it?
Wait, are you saying the visual DOM doesn't exist?
I'm saying we can't rule out the possibility that the app's performance issues are the result of external tampering by someone or something that didn't want this app to succeed.
All right, Detective Mulder, I think we've got enough.
You need to look beyond the DevTools profiler. There's a bigger picture here.
Okay, Mulder, I'll take that in mind. Moving on. So, most likely, aliens aren't causing your performance issues. But luckily, the truth is out there, and you do have the tools to uncover it. This is my performance debug methodology, and it involves several steps. The first step is detecting what gets re-rendered. And the second step is detecting why it gets re-rendered. And that's it. There are no more steps. I know you expected more, but it's not that complicated. And in order to do that, we have several tools at our disposal. So let's go through them, and I'll present them one by one, and you see which one fits your use cases. The first one is what I call strategic console logs. The best or worst form of debugging, depending on how you look at that. Second one is a library called Why Did You Render, which helps you figure out more precisely why certain components render and gives more information about the whole React rendering process. Third is React Dev Tools, which is a Chrome extension, a really powerful one. Fourth is React Scan, which is this library that you plop down on your page, and you can also kind of point it at other pages, which gives you some more information. And lastly, deleting code. And we'll go over that in a second. So by strategic console logs in the context of React, I mean something like this. Sometimes you just want to know what props changed. And you don't, in order to do that, you don't have to install new stuff or install extensions or change your app or anything. You can just use this use effect. And I know 5 minutes ago I said don't use effects, but for this instance, I allow you, and you're going to remove this anyhow after you debug, right? Because you're good. I have my trust in you. So essentially, if you have a prop status and you want to know, did it change, or maybe something else, maybe the parent changed, whatever, you can just plop this down in your code, and you can have a console log to figure out whether a prop changed. Really simple. In order to show you the other stuff, I'm going to show you an example, a simple example app, and we're going to go through how to use that tools on that app. So this is my example app, and this is the one on the left. You have two components, this name component and another component which doesn't use context at all, but when you do update name, that component will still get re-rendered, and we're going to find out why. Like, spoiler, we'll see in a second why that happens, but we'll go through the debugging process first, and then see how we figure that out. So again, to recap, it's a simple app with basically like 3 components. There's the button, there's like the name component, and there's another component with text. The name component gets its value from a context provider that has the name in it. That's the entire app. So first, let's is that clear? Yeah, good. I would have proceeded no matter what you said anyhow. So this is React Dev Tools. It's a Chrome extension that you can download and install in your Chrome, and then use that to debug your React app. And if you're in development mode, it has more information than like if you're on production. And the way it works is like this. Let's go to our app, open the extension, and then go to the components area, and then click on the cog and turn on this option called highlight update when components render. And now when we click on name, you can see exactly which components changed when something changes in the app, which is a really powerful tool for detection. And you can see that even though only the name changes, the component on the bottom still got re-rendered. So now we saw that there's something weird going on. I'm not saying that every re-render in the app is a bad thing. Sometimes stuff re-rendered and there's no performance hit. So it's not like you have to go and just like find everything that gets re-rendered in your app and like see that as a red flag. But it does give you like a good indication of maybe something re-rendering, like maybe it's not one component, maybe there's a huge section that gets re-rendered even though it doesn't have to, and that gives you more control over that. Okay, so now that we know that something that shouldn't have re-rendered did get re-rendered, let's see how to find out exactly what was the cause with React DevTools. So we go to the other React logo thing here, the profiler, and we click on record. And then we play around with the thing that triggers re-rendering. And we hit the record button again. And now you see this graph of all the different components and calls that got rendered. And when you hover over one of them, you see highlight of the actual component. So we go to the component that got re-rendered, which is the bottom one here. And you see the parent component rendered. That's what caused the render. Great. Now we go up the tree to the parent component, and it says context changed. So okay, so now we know what exactly happened. The context changed, and that caused the parent to render, and because the parent rendered, the child rendered. And okay, from this, you kind of probably figure out by now what is the culprit here, plus the code was all along the right side. We go to the context. This is like the component that uses the context. And this is the component that doesn't use the context, but does get re-rendered. And when you go to the context provider, you see that, again, to the value of the provider, we've created a new object. We create a new object every time the context value changes, which is, again, the huge crime against React that's happening here. I know it's like, it sounds simple, and you're like, who would have done that on purpose? But I've just come across so many code bases where you have those sorts of things, and it's hard to find them in retrospect. Cool. So the solution, like we saw earlier, is just to use memo and memoize that value on the render. The next tool that I want to show you is React Scan, which is a library that the easiest way to install it is just you put that reference a script from a CDN, and then it just like works. Let me show you how that works. So again, we're in this app. And then we switch to the IDE, and we paste the script just below, well, above the other scripts that you have. This reference is like the React Scan from the CDN. And now on the bottom right, there's an FPS counter, which is cool. You get the same sort of graphic for showing re-renders, and you can also select items to see exactly like what happens on re-render. So in this example, I'm selecting the parent component, and again, clicking the button. And then you can see that the context provider changed. And not only that, you can see the exact values that changed. Though in this case, the values themselves, they don't really matter. It's just the fact that the reference to the entire context object is what got changed. But it's another cool way to debug stuff. And why is this different from React Dev tools? Because this is something that, for example, you can put on a website conditionally and then like open up on mobile or on clients that don't have the ability to install an extension in order to debug stuff. Sometimes you need to, I don't know, I had in the past had to debug on mobile web views. Like if you have an app and the app has a web view and that reached like that points to React app somewhere, you don't have a way to install dev tools on a web view in an iOS app. So that's a cool way to figure out what's going on using that. Okay, and then there's why did you render? Why did you render essentially is just a library that outputs stuff to the console for you to figure out when things changed. So let's see another example. Again, you go to the IDE. After you do the installation of that library, you can just, let's see, this unrelated component, you can turn on why did you render, which is a static prop on that component. And if that prop is turned on, then when that component gets re-rendered, you can see in the console log the output that looks like this. So you have like the unrelated component, and it says re-rendered because the props object itself changed, but its values are equal. This could have been avoided by making the component pure or by preventing its father from re-rendering, not its parent. It's very opinionated about gender. And then you have the props data itself. So that's another tool that helps you figure out exactly what happened. Let me just grab a sip of water. Cool. Now, lastly, deleting code. If everything else fails, you can always just like RF, close the laptop, go home. I have to preface this. This is a joke. Don't actually run this on your computer, in case this wasn't clear. But what do I actually mean? So while deleting all of your code base would surely solve your performance issues, it might also cause some other issues with your livelihood. So the thing I'm referring to is that, let's say you don't even know where to begin because your app is huge and like lots of devs are working on it, and like something is slow, but like you can't find you can't see the forest for the trees. One thing that I like to do is, let's say like this is your root JSX with all of the different, the sidebar, the top bar, all the stuff that's been going on. I just kind of like selectively delete things temporarily, don't commit anything, and run this and see if I can glean more information. I know this is not like a super advanced debugging technique, but sometimes like my junior developers, when I told them like, have you tried deleting half the app and see if it still works? They're kind of like, what? But it's a totally and completely valid method to like narrow down the scope of where the issue is. And again, if you're not committing anything, then it's all fine. There's no risk in doing that. And a lot of the time, that kind of helps you narrow down on where the problem is or where the problem isn't. But don't RF all of your computer. And there's another question here. Okay, so this is the React way of doing things, of optimizing whatever. Do you really have to remember to do all of those stuff? Is there like a magic solution that does that for you instead? And the answer is kind of. There's a new thing called React Compiler. And this is something that was introduced a while back to React, and it's still not publicly available. I mean, it is publicly available, but it's not like a released it's just a release candidate for now. But it does work. The way it works is that instead of having to yourself do like use memo, use callback, and remember all the stuff that I talked about here, you just turn on React compiler, and it automatically does it for you. So you don't have to do any of that, which is pretty cool. But it is only available on React 18.3 and up. And also, it only works if your codebase, your React codebase is healthy. And what do I mean by healthy? So if it's written using like the rules of React, which is like a long list of stuff like that components must be idempotent, which means like that for the same inputs, they have the same output. And that hooks must run at the top level, and that hooks must not be conditional, and that side effects shouldn't run in the rendering phase. And there's lots of stuff there, which you should be doing anyhow in your React app. But if like you have a healthy code base, then you can turn on the React compiler. And if not, then you're left with everything else that was in this talk. Cool. So to sum it up, be careful with use context. It's a great tool, but if you're not careful, it's just one of the worst cases of it will cause one of the worst cases of performance issues. Use effects only if necessary. Memoize, but not too much, which means that, I mean, some components you might think are expensive, but like usually they aren't. Like if you think you have like a filter that needs to filter a long list of stuff and then to kind of like select on that and make changes and whatever, it's a lot of code, but usually, you know, you're working on lists of less than 100 things. So like there's honestly no reason to memorize most of these. And you have visibility or debug tools at your disposal. I'm gonna share this presentation later on my Twitter, probably, and also from the conference organizers said that they're gonna share it somewhere. So I don't know. Thank you so much. I'm on Blue Sky, and I'm on X, or wherever there's a user and password online. Thank you for having me. And y'all being so nice, I want to take a selfie with you. So it looks like you had a lot of fun. Yeah. That's all I get? Come on. Try again. Thank you so much. Do you want to do questions, or do you want to come up and talk to me after? I usually like to do this personally, because then like people want to go and get coffee and stuff, and then not everyone everyone's like antsy to go out. So I've decided let's do that. If you have something to ask me, come up and let's talk about that. Thank you so much.